Good morning, everyone. Welcome. Hope you all had a nice, relaxing weekend. Let's do a couple of quick announcements before we begin today. First off, actually a confession. I did not finish grading the assignment that I intended to last week. That's totally my bad. I just didn't get around to it. I don't have any excuses, really. Just didn't get around to it due to other things getting in the way. But that doesn't mean I'm going to stop trying. I'm going to keep trying to get caught up on grading. I'm officially behind now. But the interesting news, I guess, is that I'll be out of town this week. So just remember that this Wednesday we do not have class. I will not be here. I will probably still be on the plane to Pittsburgh at this moment in time on Wednesday, but we'll be in Pittsburgh from Wednesday through the end of the week. So I am still available by email if you need anything. Hopefully while I'm sitting around the airport / on the plane, I'll be able to catch up on some of this grading. That's my plan anyway. But no class on Wednesday. And then when we get back, or when I get back, and you all are probably not going anywhere, I don't know. Next week, when we return to class, that is the last week before spring break, which is really cool. But also, kind of the wrap up of the first half of this class and the shift into the project, which is going to take up the back half of this class, is going to start 1 week from today on Monday. We're going to start talking a lot about how to manage the project. So not just talking about programming by yourself anymore, but programming with team members and what you need to think about, what you need to consider when it's working with a whole bunch of people together. And then, by Wednesday of next week, I'm hoping that, or actually by the time you leave for spring break, you can see it's actually listed there for Friday. By the time you leave for spring break, I'm hoping that you'll all know who you're working with on the project and have your teams formed so that when we get back from spring break, it's just project until the end of the semester, basically. So that's kind of where we're at in this class at the moment. Only a few more classes left until we shift into full project mode. There are some assignments left, so I know that some of you still haven't turned in assignment 3. That's fine. Let me know if you need help. I am around tomorrow, so it's not too late to book an appointment with me tomorrow if you need some help on assignment 3. But I will be out of town later this week, as I mentioned, so you'll have to email me if you have questions beyond tomorrow. Assignment 4, I'm hoping to talk about. I'm sorry, assignment 4 went out last week and is officially due this Wednesday, but as I've already said, I'm out of town, so same general rules apply with the due dates for that one. Like, I hope you get it in by Wednesday, but if you don't get it into me by Friday, I guys still got a grade assignment 2, assignment 3. No harm, no foul. And then the last assignment 5, is the one that's going out today, officially due next week. But as I mentioned, I believe I mentioned last class and hopefully a couple times before that, I will accept assignments 1 through 5 as long as I get them by, hopefully by spring break, right? So that I can grade them during spring break. I will not accept assignments 1 through 5 after spring break. That is a hard deadline. Once we start on the project, I do not want to be messing with assignments 1 through 5 anymore. I want everybody to be through assignments 1 through 5 and focused on the project. So if you need time on them between now and then, please take it. That's totally fine, but very hard deadline on those assignments once we get back from spring break. Any questions on assignments, logistics, other stuff before we hop into today's topic? Yes? No, it's on what we're talking about today, actually. I'm going to review assignment 5 at the end of class. It's, I would say, I mean, the assignments kind of do a bell curve, in my opinion. The assignment 3 is definitely the peak in terms of, like, difficulty, I think. Assignment 4, refactoring, not so bad, and assignment 5 is also not so bad. So hopefully it'll be a pretty chill assignment for you, but we're going to talk about it today. Any other questions before I hop into today's topic? Great. So we're going to talk about unit testing today, and actually, specifically, we're going to talk about test-driven development, which takes this idea of unit testing and really tries to make it an integral part of the way that we code and the way that we approach our code. So the idea is that code is useless to us unless we know that it works, right? You can write all the code that you want, but unless we know that it actually does the thing that it's supposed to do, it's absolutely useless to us. And so that's why tests are considered to be so important. Tests are a way to tell us whether the code is working well or not, if we write them correctly, which is a big topic of what we're going to be talking about today. Also consider that on big projects, right, we're going to add code over time. So it's very good to know that as I'm adding things, I can still count on the fact that the old stuff is working, right? I haven't, broken something in the past by adding something in the future. So having a lot of tests allows us to make those checks and verify that everything's working. If you go get a job at a big, code factory, the Googles and the Microsofts of the world, and you try to push code to your project without your tests passing, with, any tests not passing, they're going to be like, what are you doing? Go make the test pass, right, before you push this code. That's what they're for. You just don't mess with that fact, because for the very first point I made, code that doesn't work is useless to us, right? We don't want to push that. We don't want to push broken code out to people, not intentionally anyway, right? So knowing how to write good tests is a very important skill. And what test-driven development does is says that tests are so important, we really should be writing them first. And it's a very kind of foreign-feeling concept to us, to write our tests first. For starters, I think a lot of students don't really get experience writing tests much at all. We try to write them, get students writing a little bit in 131. In upper level classes, tests are used a lot to grade your homework, right? But they never make you write the test. They're just like, here's the test, make sure you get all the green check marks, and people are very good at making sure they get all the green check marks, right? That's kind of what we train people to do. But where do those tests come from? Somebody has to make them. Somebody has to write them. And it's not going to be your professor writing tests. It's not going to be your boss writing tests for you. It's going to be you. It's going to be you writing the tests for yourself to prove that your own code works. Right? So people aren't just going to take your word for it that the code you wrote works. They're going to want you to also provide tests that show that the code works. Yes?
Are there software engineers that do specifically just tests?
Sure, absolutely. Testing is a huge part of any kind of major software that's going to hit a lot of people. User interface testing is a big deal. We actually have a HCI minor that kind of focuses on that sort of thing if anybody's interested. But as developers themselves, so it's testing is a broad category. What you're speaking of, I would say, is more related to end user testing, whereas what I'm speaking of is more testing for programmers' sake, right? So there's a lot of ground that we're trying to cover, a lot of ground that we're trying to test. If our unit tests fail, I've never been running, a website or a game or something and known, oh, hey, this game just failed a bunch of unit tests, right? That never happens to me, right? That's not for me to see. That's for the programmers to see and the programmers to know. But I have found glitches and other weird things, bugs and things in programs. That definitely happens. But that's a great question. In fact, I think it's interesting to think about, even if you aren't a tester, right? Even if you are just a programmer, how much of your time is actually spent programming versus testing? It's probably a bit more than you think, right, on the testing side, because it's very, very important to demonstrate that your code does what it says it does. I think it's not unusual to expect people to spend just as much, if not more time, writing the tests to prove that their code works as it takes them to write the actual code itself. So, that's not an unrealistic expectation, especially if you're in a program that really requires extensive testing. Think the airplanes and the radiation therapy machines of the world. You're really not going to want to mess around with stuff like that. So let's talk about how to write good tests. And I also want to try and encourage you to use test-driven development. Actually, I'm going to ask you to do it on the next homework assignment. Test-driven development. So first off, I'm going to make a project today. I'm going to make a project to represent a little menu system, like you might see if you go over to the cafeteria and use the station or whatever to punch in your order, right? Just a simple little kiosk kind of replica. But we're going to do it in Java and allow people to add items to their orders and see how much their order is going to cost, and maybe like compute the tax and stuff like that needs to happen. Leave an option for a tip, the usual kind of stuff. But every step along the way, we need to consider, should this be tested? And if so, how should this be tested? When should we be doing this testing? So we're going to start from scratch today. I would encourage you to kind of follow along with me as I do this. I'm going to go into Eclipse. This is another thing that we don't really show people a lot, right? A lot of times when you start a homework assignment, we give you a project. You say, go. I'm starting from scratch today. And on the project, you as well will be starting from scratch. So how do we do that? How do we, get our code into our repository? Well, let's start by making a new Java project in Eclipse. I'm going to call mine menu system, since that's what I'm trying to build. This is asking me what version of Java I want to use. I'm pointing this out because in a couple of weeks, I'm going to ask you to be working on a project with other people. And so they're going to be running the code that you write on their computers. And if they don't have the version of Java that's, at least as good as yours on their computer, then they're going to have a hard time doing that. So that's something that you do need to be aware of, right? And talk to your group mates about once you figure out who's going to be in your group for the project. Make sure that everybody has the most recent version of Java installed and is using the appropriate version as part of the project. But for now, I'll just use whatever's in the box and hit finish. It always asks me if I want to make this module info.java. I don't think I've ever intentionally made one of these in my life. So I always skip that step and just move on to the plain Java project. And here's what it starts me out with. It starts me out with just a source folder and the Java standard library, right? The regular Java stuff. And it's up to me then to start to decide what I want to put in first. And so I've already kind of identified that I want to have menu items and an order. And that first thing that I said in particular, a menu item, is a good example of what I would call a data class. It doesn't really do anything except store some information, right? It tells me that French fries cost, $5, and that's basically it. That's basically all that it's good for me. In this particular context, is just a way to group a set of information together. Those kinds of classes actually don't need tests. So those are the kinds of classes that are typically so straightforward that the only methods you're going to see in them are maybe getters and setters, and a constructor or two, perhaps, and not much else. And so let's start by actually not writing tests, but creating a simple class for our menu item. It's a good way to explain what not to test, right? The things that we don't need to test within our code. First off, if I'm designing a class, I'm going to think about what the instance variables should be, and I kind of just named them a second ago. But there's a relationship, and I know this is stuff from intro class, but it's always good to review. These are our has's, right? A menu item has a name, like French fries, so that's probably a string. And it also is going to have a price, right? A double price, like $5. And if you took 131 from me, and even if you didn't, hopefully you know by now that instance variables should be marked private. Always, 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 always. And we'll provide getters and setters for them should we need to. Our next task is going to be to create a simple constructor for this. And it's going to be very straightforward. I'll just take in both properties as parameters to the constructor. And set them to their respective instance variables. I'm actually, I think, pretty much done for now with this simple data class. Again, I'm not going to write any tests. I typically won't write tests for constructors. So that is one category of things that I am not interested in writing tests for. Constructors typically don't need tests. Constructors follow a very straightforward pattern a lot of the times, right? If you have a very complicated constructor that is outside of that normal pattern, then perhaps I might consider writing a test for that. But if it follows this very straightforward setting parameters to instance variables pattern, then you don't need a unit test for that. It's too basic. The same thing goes for getters and setters. I'm not going to add them right now, but later on I'm probably going to add getters and setters to this class. You do not need to write unit tests for getters and setters. The same rule applies. If your getter and or setter is doing something unusual for a getter and setter, doing more than just the typical return an instance variable, for example, then maybe you want to consider writing a test for it. But if it's just returning an instance variable, there's no need to write a unit test for that. It's so basic, it's so straightforward. Nobody's going to be confused about a getter that does that simple thing. So no need to write tests yet, but let's move on to our next object. That's going to be the order, and that I think has a little bit more things to do. It needs to keep track of, for example, what items are on the order, and I think that's kind of one of its main responsibilities, as a matter of fact. Oh, little side note here about the package. You'll notice I didn't actually create a package, so it just put it in this default package. You can do that. It's a little sloppy. It's definitely a little sloppy. So definitely better to actually rename this into something, or create a proper package, I guess is what you would need to do. CSE237.menu system or something along those lines, and keep things in proper packages. Again, for a small project, does this matter? Not so much, but imagine that you've got 100 Java files. Okay, now I really want to have different packages to make sure everything's organized properly. So I'm going to start doing that now from the get-go, so that I don't end up in that nasty situation where I have hundreds of Java files and have to figure out where they go. Did you have a question, or you just... Oh yeah, cool. So yeah, let's move on to our order class. So for our order class, it actually has a bit more work to do. And we could start at the same place that we did with the menu items. Think about the hasas, maybe even create a constructor. Although I think a true diehard test-driven development person would say, we're not even going to do that first. We're going to write tests first. So the rule of test-driven development is I'm going to write tests before I write any actual code. Always, always, always. Before I can put any code in here, I need to have written a test. A failing test, right? The test is going to fail because there's no code. But I need to have written a test that fails first. Once I have a test written that fails, I will then go write the code to make that test pass. So the big idea behind this, even though it feels a little silly to write a test that you know is going to fail and then go write the code next, instead of the opposite, right? Consider the opposite direction. I'm going to write the code first and then write the test. Consider what you're using the test to do. With test-driven development, I'm using the test to say exactly what I want to happen. Or in software engineering terms, we'd say, I'm using the test to say what the requirements are. I need my program to do this. I know my program does this when this test passes. I will now go write the code that makes that test pass, and therefore I know my code does this. It's also a nice tool to help us keep our code short and concise. So we just went through a whole section about clean code and how to make code that is, not gigantic and bloated and takes up too much space. If we use good test-driven development, it naturally leads to methods that are clear and concise because our requirements are small, tiny chunks. That's what we want. We want small, tiny chunks. We want to incrementally add things to our project, one tiny chunk at a time. We don't want to stay up all night adding thousands of lines and commit that all in one big mass. Because then, if one of those 1,000 things doesn't work, it's going to be harder for us to figure out where things went wrong. If everything is done in small, tiny chunks, we have a clear chain of what happened and in what order, and if problems arise, we can more easily go back and figure out where things went wrong. So I'm going to start by writing a test. And we need to have a requirement in mind when we write the test. What are we testing? I want to test just a simple use case of, an order should be able to tell me how many menu items it has, right? How many items are on the order? How many things am I trying to order? So let's write a test for this. Let's write a test. I'm actually going to make another package. This is a good example of trying to use packages to keep things separate. I have one package for the actual code and one for the tests. So within the test package, I'm going to make a file called object test. I'm sorry, not object test. Order test. And all of the tests that have to do with the order class are going to go in this test file. All of them. If I have another class, right, then I would put all of the tests for that class in a different test file, specifically for all of the tests for that class. Okay? We don't need a main method. We're writing unit tests, so main method is not going to help us out here. And we're just going to go ahead and start to write our first test by typing @test. And after we write @test, on the next line, we're going to put in a method. Test number of items. Right, so this is the name of my method. I said I wanted to test the case that a menu or that an order can tell me how many items it contains. So this is the method that I'm going to test. And by including this out in front of it, I'm telling Java that this isn't meant to be a typical method. This is meant to be a unit test. So I'm actually marking this. These are actually called annotations in Java. I'm using this annotation to tell Java that this method is actually a unit test. And you can see it's mad at me. It's probably going to want to add the unit testing library for me. Yeah, awesome. You can see there's 2 to pick from. I think I'm going to use 5. I'm a little unsure about that, but I think I can always change it later if I need to. And it just adds it added a import statement up at the top, but it also should have added, yeah, you can see down here it added the unit testing library to our project as well. So we've set up the shell of our test. We now have to put stuff into the test, and a good unit test follows the same format. There's 3 steps for every good unit test. It's going to do the same 3 things. Sometimes you don't need all 3 steps. Sometimes some of the 3 steps are going to be a little bit more complicated than other times. But those 3 steps are always going to be there. It's our job to make sure that our unit tests follow these 3 steps. Step 1 is set up objects being tested. So the methods that I'm testing, right, come from classes. In order to call methods from within a class, I need to create an instance of that class. So before I can test a method to make sure that this method works, I'm going to have to create an instance of an object upon which I can call that method. I might have to make multiple objects. In this case, I think that's true because orders require menu items in order to operate. So I may have to create an order as well as a menu item or 2 in order to properly test this. So let's go back to our code here. Let's create an order. Test order equals new order. And well, wait a second. We're already kind of at an interesting position. I'm calling a constructor that hasn't been written yet. So I now have to think, well, okay, this is the point in time where I have to make some decisions. What instance variables do I think this object is going to have? How do I envision the constructor of this object operating? How would I think that the constructor of this object should work? Right? I'm making these decisions now. So in my mind, right, what does an order have? What are the instance variables that it contains? There is some sort of a container or a list, right, of menu items. Probably going to use an array list or something along those lines of menu items. I think that's about it. There might be a customer name associated with the order, perhaps, or like an order number, perhaps. But in terms of what needs to be passed in, I think for now, I can probably just leave this empty. And if you disagree with me, you're like, I really think customer name should go in there. Okay, I don't have a problem with that. You're in charge of making sure that you tick the requirements properly. So if you disagree with my requirements or you want your order system to work a little bit differently, you can write your tests to reflect that fact. We're making those decisions now. We're using the tests to help us, make choices about how this code should work. I also need a menu item. So I'll make one for fries since that's what I've been talking about. This one we already know how to do. I have my menu item class already, so I can just pass in fries. Why do I keep typing that wrong? For $5, right? Better be some good fries. Menu item is unhappy probably because it needs to be imported. So because anytime it's in the same package, if I'm talking about something that's in the same package as me, I don't need an import statement. But since the test is in a different package, we do have to import this, just like we have to import the order class as well. So let's go ahead and import both of them actually. I don't think we need any other objects to be tested right now. But we do need to kind of think about, well, how do I get this menu item into the order? How do I make sure the order knows that this fries menu item is part of this order? Or I need to have a way of adding my fries to my order, right? You have a way of saying, hey, I want a cheeseburger, put that on the order. I want fries, put that on the order. How do I do that? Well, that's another thing that we have to think about and design. If I were doing it, I would say, okay, the order class is probably going to have a method. That method is probably going to be called add item or add selection, right? It's going to take in, let's start typing it out. This order instance is going to have a method called add item, and that is probably going to take in as a parameter some menu item that we wish to add to the order, right? To keep track of. And so I want to take my fries and add that into the method. And you can see, okay, this is actually the first legitimate time where we have an error that we can't really solve. At least not right now. Because I haven't finished writing my test yet. This is wrong because this method doesn't exist. But we have just justified its existence, right? I think that's kind of an important takeaway from this. By writing this test, we're saying that, well, this method needs to exist. And here's kind of how I think it should work. At least from the outside, right? What is it doing inside of the class? I don't know. I'm going to have to go figure that out a little bit later, how to hook everything up under the hood. But from the perspective of how should an order work, right? This is how I think an order should work. I should be able to add items to it. And then the next thing that we're really interested in is, okay, tell me how many items you have. So within the order class, I think there should be a method called get number of items, right? Again, it's angry because this method doesn't exist yet, but that's literally what I'm trying to test, right? That's quite literally the thing that I'm trying to test for. So the order needs to be able to tell me this information. These items I would classify as step 2 of any good unit test. Call methods under test. Every single unit test that you write has to be associated with one or perhaps more methods. Ideally, it's just one. In this case, you can actually see it's 2. I can't ask how many items there are without having some way of adding items to the order. So I have 2 methods that are kind of involved in this test. Ideally, it would just be 1. So that's what we're hoping for. If I can write a test that just tests one method, just calls one method here, that's great. That's what I'd like to do. Not always possible. Our objects interact with each other. We still need to test things properly. So we'll go ahead and call the method that's under test, as well as this additional method. The add item method, we're not really testing. It's a hard one to test. for reasons that we'll maybe talk about when I write it in just a second. At least it's hard to test directly. We're sort of indirectly testing it by checking to make sure that after I add an item, right, the number of orders is, the number of items is tracked properly. But that's the second one. And then the third one is to verify your results. But we do this in a particular way when we're unit testing with something called an assertion. So when you write an assertion, you're saying that I think this thing should be true at this moment in time, right? In our case, what do we think should be true? The number of items that we see here should be 1. That's what I think should be true. So actually, in order to reflect that fact, we probably need to store this in a variable, right? Even just doing this tells us another piece of information about the get number of items, right? I have now definitively proven that it needs to have a return type. In fact, that's true of any method that I really want to effectively test. If you're testing methods with void return types, that's going to be much harder to do because they aren't returning anything. You can use instance variables, so that is a way to get around that. But most of the time, I'm grabbing the return value and making sure that the return value from the method that I'm testing is what I think it should be. So in this case, I think it should be 1. Let me write an assertion. There's a few ways that we can do that. I can say assert equals, does it want the actual value first or the, all right, we're gonna add, we have to import it, I guess. Oh, I think, did I use the wrong version of JUnit? Is that what happened? I'm not sure. It needs 2 values. It needs the actual value that we got from our by testing the method, and then the expected value. What I'm unsure of is if that's the proper order or not. Let me see if I can get it to tell me. No, it's backwards. It wants the expected value first and the actual value second. So let me switch that. So when I write an assertion, I always have to provide at least two things: the value that I think it should be, and what the actual value is from the result of calling the method that I'm trying to test. This is what gives me the green check mark or not. If these values are equal, I get the green check mark. If these values are not equal, or if there's an error anywhere before there, I don't get the green check mark. So these assertions are really what does it for me. And as we'll see later on, I want to make it actually clear here that we can use multiple assertions. I would argue that in this case we don't need multiple assertions. Hopefully later on I can show you an example where maybe we do in fact need multiple assertions to properly prove a test. But think about the case where it's changing multiple values. Perhaps we have to make sure in order to properly pass the test that we're checking all values that may be affected by the method that we're calling. So not limited to just one assertion. You can absolutely use more than one to verify that things are working. This is a good test. So now that we've actually written this, test-driven development says, okay, we have a test, it fails. Almost always it's going to fail because this method doesn't exist, although very possible that I'm testing an already existing method for some new situation. That's very possible as well. But the first case is always write a test that fails. I'm going to write this test that fails the code, or that fails the unit test, and now I'm going to switch over to writing the functional code to make this test pass. So let's go over and do that in our order class. The nice thing about test-driven development is we've already made a big chunk of the hard decisions by writing the test. So now this part should hopefully be pretty smooth, pretty straightforward. I've already talked about how I think this class should have an instance variable that is some sort of a list, some sort of a collection. You could use an array if you want to. I think a list is going to be cleaner. So, I'm going to make an array list of menu items called order items, right? I can already tell from my test what I want the constructor to look like. I can see that here I chose not to have any parameter, just use the default constructor. That's great. So the constructor still does, however, need to initialize my instance variables. Yeah, question.
Should it be menu item?
I'm sorry? Oh, it should be, yeah, menu item singular, not plural. Thank you. Yeah, good catch. This also needs to be imported, as we usually need to do. But yeah, for the order constructor, we've already made the decision that it doesn't need any parameters. So I don't even need to think about that right now, other than to make sure that it matches the test, right? And then go on and continue to write the code. So I do need to initialize this variable. Every order starts empty. That makes sense to me, that every order would start empty until somebody decides that they want to order something. Okay. Still haven't passed the test because we still don't have these methods. These methods don't exist yet. Let's start with this one. In order to, ask it how many items it has, I first have to add this item. So, all right. The way that I've written this test, you can see I'm not keeping the return value. So I've already told you indirectly that the return type of this should be void. So, all right, should be called add item. I've already decided that's what the name should be. I've already decided that it should take in a parameter called menu item. And the only real decision that we have to make is what goes inside of the brackets here. Well, I'm probably just going to stick it onto this list, right? There we go. And now, finally, we can get to the real method, the one that we really truly care about, which is get number of items. We can see that that one has to have a return value, a return type of int. I can tell that by looking at the test. So I'll call it get number of items. You might be thinking to yourself, well, hey, we just said we don't have to test methods that are getters and setters. Well, this actually is not a traditional getter and setter, right? This is not going to return an instance variable. It's going to return, more specifically, the length of the instance variable, or the size of the instance variable. I admit that this is a bit of a tiny example, but we'll do a little bit more complicated one after this, probably. And if we go over and look at our unit test now, we can see that it actually is no longer complaining about anything being missing or any methods not working. We wrote them. We wrote the code to pass the test, although we still need to prove that. We still need to run this unit test to make sure that it does, in fact, pass. So let's go ahead and run that as a unit test, and hey, awesome, it passes. Number of items passes. I actually don't think that we're quite done with this just yet, but I want to pause right here and see if anybody has any questions about the three pieces of the unit test, and also this idea of writing tests first and then writing the code. Any questions, any concerns? I want to get some more practice. It does probably feel weird. It felt weird to me too the first few times that I did it. I'm not used to writing tests that much at all, much less first. But I'm trying to get you some practice, trying to get you used to this idea. You can see that the methods that were generated are, in fact, very short and sweet. That's good. think it does help us write methods that aren't going to get overly bloated and overly big. We have to keep them simple in order to test them effectively. The bigger, more complicated a method is, the harder it is to test. A fact that I'm willing to bet a lot of you are going to figure out in the project in a few weeks. So just a little something to keep in mind. All right, so this method, get number of items, I would say we did test it. Well, we didn't test it very thoroughly, right? In fact, I would argue that I kind of spoke about another test that should be written, which is that an order, when it's first created, should not contain any items on it. I think we could write a test for that as well. I think that test is probably going to look a lot like the test that we just wrote, as a matter of fact. So let's go ahead and do that one. You might be arguing, okay, it seems a little silly to write a test that's going to be almost exactly the same as this one. But it's valuable, it's useful. Again, for the case that, what if I write code a year from now that changes the way that orders work? I need to know that, right? I need my tests to fail and tell me, hey, this change you made, it's going to have some serious impact. Going to have some serious effects. So let's write another test. Test empty order. Sometimes what I might do up here is even put the use case that I'm testing, right? An order should be empty when it is created. That way I know exactly what this test is supposed to be testing for. Same 3 steps. In fact, it is going to look very similar to this one. So I'm going to start by copy pasting and then just tweaking a little bit. Whoa, except I didn't paste that very well, did I? Or did I paste it in the wrong file? The menu item isn't really needed at all. I'm testing an empty order, right? So we can get rid of anything that has to do with the menu item. This is an even simpler test than the last one that we wrote. The other thing we need to make sure to do is change this to say 0 for our expected value instead of 1. Now we can run this again. See that? All right, cool. Now we have 2 tests that pass. Great. I kind of did this a little bit backwards, though. Real hardcore, test-driven development person would say actually both of these tests should have been written first. And not only both of these, but maybe another one that tries to put on like 5 items just to make sure that it's not going to collapse after just one, right? True test-driven development would say, write as many tests as you can possibly think of for this method before writing it. But that's okay. I think I'm not as such of a stickler for those rules. I think anything that gets you writing good tests, especially early, is a good thing. I do kind of personally have a habit of writing some tests first and then thinking of more tests later and coming back and writing them later. Always good to have more tests, so I'm not going to complain whether you give them to me first or last, as long as you think about them early and often. That's really, I think, the important thing. But yeah, let's try something a little bit more complicated. I want to do this one more time, and then we'll probably switch gears and talk about the homework assignment for the last part of class. I want to do this one more time with the total. So I want to make sure that it can actually process the total correctly. So if I add, a few things to the order, it should give me a few different totals, right? It should give me the subtotal. It then needs to compute the tax that's based on subtotal. That's its own separate thing, I think, honestly. Computing the tax is its own separate thing that can be tested. And then it should give me the grand total, which is the subtotal plus the tax, or maybe any tip if I want to include tip in there as well, right? So I'm just going to focus on the subtotal for now, the sum of all of the items on the order. How much does that cost? So let's start by writing our test. At test public void test order subtotal. That's what we're doing, right? Testing the subtotal of our order. Step 1 is set up the objects. And all right, I'm getting a little bit tired of having to do, you know, this thing over and over and over and over. The good news is that I don't have to. This is a pretty well recognized problem. There's a way that we can have the unit tests help us with this step. There's a method, a special method, or a special annotation rather, called, I believe it's called before each. Might have to Google that and see. Yeah, before each. That's what I was looking for. And the way that this before each annotation works is exactly the way that it sounds. The method that is associated with before each is going to run before each unit test runs. So in other words, the method that I'm about to write is going to be called before all of the test methods. So it'll call the before each method, run test number of items. Call the before each method, run the next test. Call the before each method, run the next test. And so these methods are good for setting things up. If I know I'm going to need an order object in all of my tests, then I'll just put it in this method, and now I don't have to put it in every single one of my unit tests. So let's finish writing our test setup method. We're going to use a little trick here. We're going to use instance variables. Our tests can have instance variables as well. Call this test. What did I call it down here? I called it test order. Yeah. So now I'll say test order is equal to new order up here. And what that allows me to do is come down here and remove all of these from my tests. And you can see that once I did that, it started to refer to the instance variable instead, which is good. That's what I want. I'm going to do the same thing here too. And maybe since, you know, I wouldn't do this in a normal unit test, but since we're learning about stuff today, I'll just leave a little note here to myself that the before each is handling this step for me in this test, right? That step's still happening, it's just not happening here. I've consolidated it up top so that I don't have to keep doing it at the beginning of every single test. We could do the same thing for menu items as well. So, you know, if I wanted to have a few menu items to test, which I do actually, I could have those be created as well, just so I have some simple things that I can use with my orders to test. We'll set these up here too. Coke is going to be $2.50, and a burger $10. Notice that I did keep these. Oops, that's a typo. I did keep these numbers, you know, somewhat reasonable in terms of I want to be able to easily figure out what these tests should be computing. If you're doing things that are doing some heavy number crunching, right? Research kinds of tasks, for example, then, you know, yeah, you would have to be a little bit more careful about how you test these numbers. But in general, I do want to pick numbers that are easy for me to self-verify, since I'm going to have to write these tests later and figure out what the actual values are supposed to be. Yeah, so we don't need to do this anymore either in this test. That really simplifies step number 1 for us. And now over here, you know, this is also done in the before each. You don't have to do it that way. If you really want to create the object at the beginning of every test, you can. But this definitely helps clean things up. Step 2. Call methods being tested. In this case, I need to add a few items, right, to my order. So I'll say test order, add item. Sure, we'll add the burger. I'll add all 3. Why not? Or I could add 3 burgers if I want. That's fine too, but I'll add the burger, the Coke, and the fries. And then the real method being tested is computing the subtotal. So let's go ahead and call that compute subtotal. That's probably going to give me the subtotal back as a return type, right? So I need to capture that return value in a variable. And then step 3 is to use assertions to verify the results. So here I would say assert true, or yeah, assert equal, sorry. It wants the expected value first, which is going to be 17.50, right? For lunch, for this particular lunch. 17.50. The actual value, and then for this one, it's actually going to be a little bit unhappy with me until I provide a third value as well. Remember, we're using doubles here. Doubles are not exact values. Doubles have errors associated with it. People notice this a lot, even in 131, when it gives me, why did it give me 10.000001 instead of just 10, right? It's rounding errors. So whenever you're using doubles and you're running assertions, you have to give a tolerance. You have to say that I will accept equality within this amount of rounding error. So the third value is that tolerance, where I would define that as some very small value, right? Why are you unhappy with me now? Uh-oh. Is it assert oh, it's assert equals with an S. There we go. Yeah, that worked. Forgot the S. Okay, this test will fail. Actually, maybe should have run the prior tests and shown them failing as well, because that is step 1 of test-driven development. This test should fail. There it goes. It fails. It's failing because this method doesn't exist yet. Well, we've justified a need for its existence. Let's go back and make it exist. Public double. We've already decided on the return type. We've already decided on the name. When we wrote the tests, we made these decisions, right? So we just need to figure out how this method works. I'm going to use a for each loop. This is just a classic accumulator pattern. This is a classic 131 problem. Start your sum value at 0. Run a loop through the list. So for each menu item in my orders list, what did I call it? Order items. Then sum is going to be plus equals I dot, oh, well, here we go. I have now, just finally, justified the need to put a getter into my menu items class for the price. So let me go back to my menu items class and add that getter. You can type it out. This is a simple thing, right? Or you can use Eclipse to do it for you. I think it's good to know how to do this because it's quick and easy. You go to source and then generate getters and setters. I'm going to be very, very strict today and only generate the one that I have just justified the need for. You might argue that some of these other ones will be necessary to make this order system work, and I wouldn't necessarily disagree with you, but I'm going to wait until I've fully justified the need for their existence. The only one that I have justified right now is a getter for the price. So I'll plop that in there to make sure that this works. Since I need it to compute the sum properly, we'll return that sum. Oops, what are you upset with me now? Oh, I just need to save. Do a Control S save. There we go, yeah. Alright. I've now written the code that computes the subtotal. Hopefully, when I run this test, it will verify that assertion properly. Boom! Yes, all tests pass. Another instance of using test-driven development to help us make decisions about the code. Notice that a lot of the hard decisions were already made by the time I started writing the method. It allowed me to focus on the execution of the method and not have to worry about return type and parameters and all that stuff. Any questions? Just a few things that I want to say about this before we switch over and talk about the homework assignment for the last part of class for today. I mentioned that this is nice and you don't have to use it, but I think it is a good idea to use. It kind of leads me to, or it's a good way to kind of remind yourself of the fact that every test is independent of every other test. I think that's a very, very important thing to keep in mind, right? The code that I write in this, oops, where's my cursor? The code that I write in this test is completely independent of the code that I write in this test. In other words, every time I put this test annotation out in front of a method, I'm starting from complete scratch, right? I cannot assume that any of the other methods are gonna, interact or do anything in any sort of way other than what I put in my before each. That's the only thing that I can really control. If you write tests that interfere with each other, that's a bad thing. So if you write tests that are conflicting with each other, if you write tests that require the tests to be run in a certain order in order for the tests to pass, that is a bad thing. Tests should be independent. They should not depend on a particular order to pass. Tests should very clearly just tell you, yes, it works, or no, it doesn't. Shouldn't have to require somebody digging into a bunch of data to determine whether the test actually passes or not. That's why we use assertions. So it is a tricky skill, though, which is why I want to get you some practice with this skill on the next homework assignment. Although, actually, I forgot about one more thing I want to show you today. I want to take this code and I want to put it into a repository and ship it to github.com. How do I do this? I started this from scratch. This whole thing did not exist before I got here today. It does now, so how do I get this into a repository on GitHub so that I can add my buddy to it and have them start making contributions as well? Let's talk about how to do that. I'm going to use the command line. I actually think the command line is a great way to be able to do this. So I'm going to fire up my command line here. All right, first thing I need to do is go to the directory that has that Eclipse project in it. So if you created the project yourself through Eclipse, it'll be in your workspace. Or if you're unsure, you can always actually ask Eclipse to tell you where it is by looking at the properties. So it tells me here, right? It's in the Spring 25 workspace in my home directory in a folder called Menu System. So, all right, Spring 25. There it is, right there, Menu System. That's where it is on my computer. Your computer might look a little bit different, but here's the code. Here's the stuff. This is the stuff that I want to be in the repository. Actually, the first step is to go to github.com and make a repository. So I'm going to go to github.com, and I would encourage you, to try this as well if you want to. I'm going to call mine Menu System 25 because I've done this example before, so I have to distinguish it a little bit by putting the year on the end. We've already gone through this process before. I've already kind of talked about this stuff a little bit. I think it's a good idea to add a README file. I'm going to ask you to do that for your project. But once I create the repository, what I really need is this URL, or you can find it here as well. So go ahead and copy that and return to the command line. We're going to say git init. That turns this directory into a repository. We can now add stuff to the repository and commit stuff just like we would normally. So I'm going to add the source directory. I don't want to add the bin directory. Remember, we don't put class files into repositories. The bin directory is where all those class files are. So don't put the bin directory in there. I'm going to add the source. Since I'm using an Eclipse project, there's actually 2 hidden files that you should be aware of. You can see them if you use ls-a. The first one is this .classpath file. I can actually show you what's in there. It shows you what version of Java I'm using right here, as well as the fact that I'm using JUnit to do unit testing. So it's just making sure that all of the necessary things are there for this code to run properly. So we also need to add that file, the class path, and then the other file that we need to add is the .project file, which if you open that one up is also pretty straightforward. It's quite literally the name of the project, the fact that it's a Java project. If you use another IDE that's not Eclipse, it might be slightly different, but we're going to add the .project file. All right. You can see that I haven't added .settings and I haven't added the bin directory. I've already talked about the bin directory and why you shouldn't add that. .settings is my Eclipse settings, so that's what makes my font really big and makes the text colors the way that I want. So that should not be committed either. .settings should not go in the repository. Your group mates will be mad at you if you do that because it'll make their font look like your font, and they probably don't want that. So once you've got everything added, we can do the commit. Making sure to put in a commit message. And now we can finally connect this to github.com by saying git remote set origin. That's a lengthy command, I know. And I'm not even 100% sure that I got it correct, so this might error out, but I'm going to try it. And then paste that address on. Oops, yeah, I got it wrong. Git remote set -URL. Okay. Let's try that. Okay, I'm gonna have to Google it because I clearly don't remember how to do it. Git set remote origin. Help me out. Git remote add. Oh, it should be add. Got it. Not set. It should be add. My bad. Add. There we go. Third time's the charm. Beautiful. No complaints this time. And now, if everything did in fact work properly, we should. Oh. Git push origin. Hello. Git push origin master. All right, finally. I don't know why it made me use the full syntax of the push command, but if you are ever forced in this situation like I just was, the way to interpret this is git push, obviously. Origin, where are you pushing it to? I want to push it to GitHub. The origin is what I just set to be the GitHub repository in the previous step, and then this is the branch. What branch are you pushing? So I'm just pushing the default master branch or the main branch or whatever it happens to be called on your machine. Once you finally get that to go through, you can go back and refresh the page and hopefully see that. Okay, where's my stuff? Oh, here it is. Oh yeah, that's great. It was called main on github.com, but master on my computer. That is a fail right there. That is a big not good thing that I just did. So I'll have fun fixing that after class. That's not a you problem, that's a me problem. Let's talk about the assignment. Assignment number 5, the final assignment before the project. I'm asking you to write unit tests. Specifically, I'm asking you to write unit tests for a spell checker. This is assignment always kind of throws people off a little bit because I'm not asking you to write a spell check. I'm not asking you to give me code that properly checks spelling. Some people choose to write it, even though I'm not asking them to do it, I guess just because it makes them feel a little more comfortable that way. I think that maybe for the first few, that's perhaps not a bad idea, but I think as you get towards some of the harder tests at the end of the assignment, you're not going to want to write a spell checker anymore. It's going to get a little bit too complicated, and maybe not so worth your time. But all I need from you are unit tests. All I need from you for this assignment are unit tests. And so if I scroll down here, there's a list of, I would call these requirements, right? These are use cases. These are things that we want our spell checker to be able to do. So you can see the first one kind of starts very similarly to the one that we worked on today. Although don't overcomplicate it, I want to say right now that there's only, you don't need a word class. I think sometimes people think that they need an equivalent to the menu item class. You do not. You can use strings. Please use strings. Please do not make a word class. Please just use strings. Please. Don't make it more complicated than it needs to be. So think about what that means. A spell checker, when I first create it, it's probably empty. It probably doesn't know the correct spelling of any words. So the first thing that you need to do is add words to the spell checker. Tell it these words are spelled correctly. It's that then later, eventually on, right, you're going to say, hey, is this word spelled properly? It's going to go look up the list of words that you've told it. It's basically a dictionary, right? The spell checker is basically a dictionary. It's basically saying, okay, you told me about this word. So that means it must be spelled properly, right? Or I can't find this string anywhere on my list of properly spelled words, so that string is not spelled properly. That's kind of how I envision this spell checker working. I just gave you kind of a big bunch of hints in that last couple sentences there about the execution of this theoretical spell checker. But what I want you to think about are what methods should be in the spell checker class. I'll tell you right off the bat, there's going to need to be an add word method. It takes in a string, right? Make sure that the spell checker is aware that that string is spelled properly. Don't add incorrectly spelled words to the spell checker. It doesn't care about those. It just needs to know about the words that are spelled properly. And then I can feed a word to it and say, hey, is it spelled properly? It's just going to give me a thumbs up, thumbs down, right? Yes, it's spelled properly. No, it's not spelled properly. So for each one of these requirements, you need to write at least one unit test. So there are 8 of them, I believe. 1, 2, 3, 4, 5, 6, 7, 8. Yes, there are 8. That means that I want you to write at least 8 unit tests for these, 1 for each of these requirements. Some of them I think you honestly could justify writing more than 1 unit test. I'm not asking you to do that. Just asking you to provide at least 1 unit test for each of these 8 requirements to justify that a spell checker works. I am not, again, not asking you to write a spell checker. You do not need to make this happen. You just need to write the tests that I would use should I want to make this spell checker, which I do not actually want to do. And just to kind of give everybody a nice little head start here, I'm going to even do the first one right now. We got 10 minutes left. Let's do the first one. As a group, create my repository and import it into Eclipse really quickly. Oh, nope, I need to import. All right. Where'd you go? Where'd you go? Where did it go? Oh, is it called homework 4? That's unfortunate. It's actually homework 5. That's also my bad. I'm gonna go try to fix that after class. I'm sorry about that. Oh, that's gonna drive me crazy, but sorry about that. All right, here we are. This is what you're gonna get when you get your repository in there. The first test said, what? A spell checker should know, what did it say? It said a spell checker should know should be able to tell us how many words it currently knows about. Okay. Very similar to the one that we, just kind of talked about. Spell checker word count. All right. Step 1 is to create the object that we need in order to run the test. I need a spell checker object. That is the object that we are writing tests for. Okay, so how should the spell checker, constructor work? How should the spell checker be created? New spell checker. Do we need anything inside of these parentheses or not is basically the question, right? Does a spell checker need parameters? Think about what the instance variables of the spell checker are going to be. There's going to be some kind of a collection for it. I think for the purposes of this assignment, it doesn't even really matter what that collection is. I would probably use a list maybe, but it doesn't really matter. I'm not sure it really needs anything else. I would argue leave this blank until you actually have a good reason to put something in there. For this purpose, I think it's fine, right? I need to have a way of getting words into the spell checker. So, okay, that's kind of similar to the example that we just ran. So I'm doing step 2 now. Call methods being tested. I need to add a word, a properly spelled word, right, to my spell checker. So I'll say cat, right? Okay, so that tells me that a spell checker should have a method called addWord. It tells me that that method should take in a string, right? And it tells me that there's probably not a return type because it's not returning anything. And then finally, in order to properly test this, I need to do kind of similar to what we did before. I need to say, hey, get number of words before I do step 3, which is write assertions to verify results. All right. I'm going to assert equals, well, the actual number of words I expect is 1. The expected number of words I have to grab from this return value, or the actual number, yeah. The expected number is 1. The actual value comes from here. If this looks very similar to the unit test that I just did with the order items, that's not a coincidence, right? I kind of did have this assignment start out similarly, but it takes a turn, right? It definitely goes in a different direction as you get to some of the later items. Just trying to make sure you all get set up, started off on the right foot. This test satisfies this condition right here. You do not have to do that one anymore. We just did it together. So that one is kind of a freebie. However, I'm not going to give you the code for this one, but let's chat briefly about some of these other ones, logistically about how you would test them. Starting with the next one on the list. The number of words that a spell checker knows about should go by 1 whenever a new word is added. Okay, think about what needs to happen, right? I actually need 2 values to pull this off. I need to know how many words are in the dictionary at the beginning. I need to add a word. I need to ask it again how many words that it has. And then maybe do some subtraction and make sure that the result is 1, right? It's gone up 1, in other words. It's gone up by 1. It was 1 greater than it is before. So think about the tests that you would write. How you would actually write an assertion for that. Right? You could actually assert it equals in a different sense. I think this is one that's kind of an interesting one for using multiple assertions. I could write one assertion to say, this is what I think the value should be, the exact numbers, but I can also write an assertion that says the value that comes second is 1 more than the value that came first. You could write an assertion for that. And I think that is a valuable assertion to write. So something to keep in mind, right? Later on down here, you're going to have to add another method or think about another method, one that I haven't talked about or shown you in the code yet. So it does get a little bit more complicated towards the end. I won't complain if you do start writing some of the spell checker code, although I would encourage you to abandon that strategy. It gets a little tricky towards the end, but if it makes you feel comfortable, helps you get through the assignment a little easier, I don't have a problem with that. And just like the past few assignments, to submit this, I'm asking you to do your work on a branch, so all you have to do to submit it is send a pull request, and I will drop the grades right there in the pull request once the assignment is done. Are there any questions that I can address about this assignment before we wrap up for today? All right. I am recording this. I did drop a bunch of hints and a bunch of good info about the assignment, so hopefully you go back and take a look at that video when you actually get around to working on this. But I'm gonna stop talking for now and let you all get along with your day. Have a good rest of your week. Again, I won't be here Wednesday, so I'll see you again 1 week from today. No class on Wednesday.